How to calculate FWHM in Origin. Welcome back. You're just in time for something awesome today. We learn about how to calculate FWHM in Origin. And before dive in, if you need good help into more understanding about it, a genius writer, a brainy tutor, or a data analyst, Intudo for you has them all. It's like having a research dream team on demand. So visit it right now. And if you are new here, then subscribe now for more amazing video just like that. In this video, we'll learn how to calculate the full width at half maximum, FWHM, using Origin. As you know, the FWHM value is needed from XRD data to calculate the crystallite size using the Scherrer equation. In this equation, all other parameters are known except beta, which represents the full width at half maximum, and it must be in radians. So in this tutorial, we'll see how to find FWHM in Origin step by step. Let's start with our XRD data for pure LIF, which contains two columns. 2 theta, values. Intensity values. We'll open Origin, where a new workbook appears as Book 1. Now, we'll simply drag and drop our data file into the worksheet, and the data will appear here. Next, we'll plot the data. Once plotted, we can adjust the legend to remove any extra labels for clarity. Now we can see the XRD pattern clearly. Since we only need the main peak, the one with maximum intensity, to calculate crystallite size, we'll zoom in on that specific region. This helps us view the peak in more detail. For more tutorials on data analysis, research techniques, and scientific writing, visit intudo4u.com. Your one-stop platform for writers, tutors, and data analysts ready to help you achieve excellence. After selecting the main peak, it's time to fit the peak. Go to Analysis Fitting Nonlinear Curve Fit. This opens the Fit dialog box in Origin. From the function list, choose Gaussian, Gauss, as our fitting model. Click Fit until converged. The fitting will iterate automatically until the curve matches the data. Once the fit is complete, click OK. Extracting the FWHM. Origin now generates two new sheets. We only need the one named FitNL1. Open it, and you'll see all the fitted parameters listed. Here, we can find our FWHM value, which in this case is 0.23694. Important, this value is given in degrees. Before using it in the Scherrer equation, we must convert it to radians. That's it. We've successfully calculated the full width at half maximum, FWHM, using Origin. You can now use this value, in radians, to determine the crystallite size from your XRD data using the Scherrer equation. Thank you for watching this video.